Energy is the ability to do work or to produce heat. And we give the letter W for work and the letter Q for heat. So it's the ability to do work or to produce heat. And the first law of thermodynamics, it's the law of conservation of energy, which states that in any chemical reaction or a physical process, energy can be converted from one type to another, but it cannot be destroyed nor created. We cannot create energy out of nothing, and we cannot destroy energy to zero. This is the law of conservation of energy, which is also the first law of thermodynamics. Look at this image here. For example, the water will provide energy to these turbines. Also, the sun will provide energy to these solar cells, and eventually it will be converted into electrical energy. Let's talk now about the types of energy. We have the kinetic, potential, mechanical energies, nuclear energy, ionization energy, chemical, electromagnetic, thermal, sonic, and gravitational energy. But we have very important energies that we need to focus on. These energies are the radiant energy, which is it comes from the sun, and it's the Earth's primary energy source. We call it the radiant energy. We have the thermal energy that we are studying in this section, which is the energy associated with the random motion of the particles, could be atoms or molecules. So we're talking about the random motion of them. We call it the thermal energy. Number 3 is the potential energy, which is the energy available by the virtue of an object's position. It's due to the object position. Number 4 is the nuclear chemistry, or the nuclear energy, is the energy stored within the collection of the neutrons and the protons in the nucleus or in the atom. So it's about the energy stored within the collection of the neutrons and the protons. Number 5, the chemical energy is the energy stored within the bonds of the chemical substances, between the atoms that form the chemical substances. For example, if we have H2O, this bond, it has specific energy. This bond, it has specific energy. We call it the chemical energy or the chemical potential energy. Now, new set of definition, heat and work. Heat is the transfer of the thermal energy between two bodies. One of them is hot and the other one is cold. And we call it heat, which is energy. And it's the transfer of the thermal energy between two bodies that are at different temperatures. But the temperature is the measure of the thermal energy. And a lot of students, they think that the temperature equals to heat, which is incorrect. Temperature does not equal to heat, because the temperature is the measure of the thermal energy, whereas the heat is the transfer of the thermal energy between two bodies. Now, thermochemistry that we are studying in this chapter is the study of heat change in the chemical reactions. We also have this definition, which is the system, which is the specific part of the universe that is of interest in the study, usually where the chemical reaction occurs. Could be in a beaker, could be in a flask. We call it the system. And we have 3 types of the systems. The first type is the open system. As you can see here, it's open. So basically, if you have here water and you are heating up this water, you are giving energy, external energy. This liquid water, it will be converted into the water vapor, and this water vapor will escape from the system going into the surrounding. So that means the exchange here in the open system is in the mass and in the energy in the heat. And also we have the closed system. There is no exchange in the mass, but only exchange in heat. And the last type of the system is the isolated system. As you can see here, it's completely isolated. There is no exchange in mass. The water vapor will stay inside, and there is no exchange in heat. It's called the isolated system. These are the three types of the system. All right. Now, types of thermochemical reactions. We have the endothermic process, exothermic process, and we have the endothermic process. Exothermic, it means release energy, exit of energy. It means that any process that gives off the heat or release energy or heat, that is transfer the thermal energy from the system to the surroundings. Endothermic process is any process in which heat has to be supplied to the system. It means that the system will absorb the heat from the surrounding. So it's going to be absorbed. Look at these two graphs. Here are the reactants and they have this energy. Here are the products, they have this energy. Obviously, it's the products, they have lower energy than the reactants. And that means the heat, because they have lower energy, the heat was released by the system to the surrounding, and that's why this this process is going to be exothermic reaction. In this diagram, the reactants here have lower energy than the products, and that means the chemical reaction absorbed the energy. That's why the products have higher energy than the reactants. They absorb energy, which is endothermic reaction. In the following lessons, you will find that the exothermic, the heat or the energy for this reaction is, or it has negative sign because the heat was released, it was lost by the system. And the endothermic, the heat has positive sign because it was absorbed by the system, it was gained by the system from the surrounding. Let's check these two examples. The first example is when hydrogen gas reacts with oxygen gas, it will be an exothermic reaction because the reactants have higher energy than the products, as you can see here. So the reaction is an exothermic reaction, sorry, and the heat was given off by the system to the surrounding. And it's going to be a negative sign. The other example here, if you have the reactant, which is the mercury oxide, it will decompose only if we supply heat externally. That means it's an endothermic process because it will absorb the heat to decompose to give you the mercury liquid and the oxygen gas. So this one is an exothermic process, and this is the endothermic process where the energy was absorbed by the system from the surrounding. Now, the first law of thermodynamics, we studied the first law. It was like energy can be converted from one form to another, but it cannot be destroyed nor be created. That's why if you look at the butane here, which is C3H8, this is the gas that is used in the cooking. This is an exothermic reaction. So the delta U of the system, U, as you will see, is the change in the internal energy of the system. The change in the internal energy plus delta U of the surroundings, the change of the internal energy of the surroundings, is always equals to zero, according to the first law of thermodynamics. That means the energy lost by the system to the surrounding equals to the energy gained by the surrounding. The change of internal energy of the system always equals to the negative change of the internal energy of the surrounding. So the chemical energy lost by the combustion system equals to the energy gained by the surrounding. And another form of the first law of thermodynamics is delta U, which is the change in the internal energy of the system. It equals to heat plus work. And we have this equation also. The work is equals to negative pressure P multiplied by the change in the volume V, delta V. And it always has a negative sign. Now, we need to study the sign of Q and the sign of W. Let's start with the sign of Q here. Heat is a Q. The heat absorbed by the system from the surrounding is going to be an endothermic process. That means it's positive sign. And the heat absorbed by the surrounding from the system is going to be an exothermic. It means that the system has released this energy to the surrounding, and it's going to be a negative sign. Now, what about the work? The work done by the system to the surrounding is negative sign, just like heat done by the system to the surrounding. From the system to the surrounding is negative. So the work also done by the system to the surrounding is going to be negative. Now, suppose that we have a gas, and this gas is expanding. That means the volume is changing, is increasing. And we have this formula, which is W equals to negative P delta V. When the volume is expanding or the gas is expanding, that means the volume is increasing. As you can see, this is V1 and this is V2. V2 now it's higher than V1. And that means the sign of delta V, because it's V2 minus V1, is going to be positive, and therefore the work is negative. That means when the work is done by the system to the surrounding, that means the gas is expanding, the work will have negative sign. And when the work is done on the system by the surrounding, that means the surrounding is compressing this gas. So that means the gas is getting lower volume. It means compressing. And that means delta V now is negative sign because the gas was with a high volume or higher volume, and the final volume is lower volume because the work was done by the system on the surrounding. By the surrounding on the system. It's going to have a negative sign. On the system by the surrounding. So it's going to have delta V is a negative sign. That means the W negative multiplied by negative is going to be positive sign. These four statements are very important in the problem solving. Now, let's have some examples about the heat and the work and the internal energy. A certain gas expands. So this one, it will tell you that W or delta V should be positive. Therefore, W is or has negative sign. It expands from 2 to 6 liter at constant temperature. Calculate the work done by the gas if it expands A at or against a vacuum and B against a constant pressure of 1.2 atm. Now, let's solve it for A. As it says here, vacuum, that means P equals to 0. There is no pressure. And this is the trick of this problem. Vacuum, it means the pressure equals to 0. Now let's apply our equation, which is W equals to negative P delta V. And of course, it will equal to 0 because 0 multiplied by delta V. Now, in B here, the pressure we have it 1.2 atm. It's not vacuum anymore. And V1, it equals to 2 liters, and V2 equals to 6 liters. That means delta V here, it equals to positive 4 liter. Applying this equation, it's going to equal for B 1.2 multiplied by 4, which equals to 4.8. And the unit is, because pressure multiplied by volume is liter ATM. When we do the work, or when we calculate the work, work has the unit of joule. And we always need to have it in joules. So we need to use a conversion factor. 1 liter ATM, it equals to 101.3 joules. This is a new conversion factor that we always need to memorize and use whenever we solve it for work. Because we don't like the unit liter ATM for work. We use the unit joule for work. So we need to use this conversion factor. I need to cancel the liter ATM. I need to find the unit joule. So I'm going to find the work in joule by the unit cancellation. So it's going to be 4.8 liter ATM multiplied by our conversion factor. I need to get rid of the liter ATM, so I need to put it in the denominator, liter ATM. And here I'm going to put joule because I need the unit of work in joules. Now, 1 liter ATM equals to 101.3. So after we do the cross multiplication, it's going to be 4.8 multiplied by 101.3 equals to 486.2 joules. Or we can convert it, of course, to kilojoules by dividing by 1000. All right, and that's it. Look here, the sign of the work here is positive because the delta V here, the sign is going to be negative. Don't forget, here it's going to be negative. And the delta V is positive, that means the work has the negative sign. All right. In question number 2, the work done when the gas is compressed. That means the work, once I see compressed, that means the W or the work was done from the surrounding to the system. So it's going to have positive or negative. It's going to have positive sign because compressed, that means V1 was big, V2 was smaller, so delta V here, I'm going to write it, has negative sign. Negative multiplied by negative is going to be a positive sign. And it makes sense when we look at this table. When it's done on the system by the surrounding, it's going to have a positive sign. All right. Now, this is the first conclusion because they say it's compressed in a cylinder and the work was 426 joules, 462 joules. During this process, there is a heat transfer of 128 joules, also the same unit, from the gas to the surrounding. So it's from the system to the surrounding. It's going to be an exothermic. That means the sign of this heat should be negative because it's from the system to the surrounding, as you see here. The heat absorbed by the surrounding from the system. That means it was released by the system and it has negative sign. That's why this table is very important, as I told you. Calculate the energy change for this process. We know from the first law of thermodynamics, delta U, it equals to W plus Q, which equals to W here we have it 462 and it's positive, minus, because this one was exothermic, so minus 128. And because the two units are in joule, we don't need to convert. we can do it. But if one of them was in kilojoule and the other one was in joule, I need to unify the units. If the work was in liter ATM and the Q was in joule, I also need to change or convert the unit from liter ATM into joules in order to do this subtraction, which equals to 462 minus 128 equals to 334, which is positive joules. This is how we solve the problem about the internal energy from work and from heat. Next lesson, guys, is going to be the thermochemical equations. We need to study something about Hess law and the heat of formation, heat of fusion, heat of combustion, a lot of heats. So I hope you guys learned something new today. If you have any question regarding this lesson, I hope you write it in the comments. I will read all the comments and I will answer all your questions. Have a nice day. Bye bye.